Hi, this class we are going to talk problems in capacitors and electric potential. Capacitors connected in series, basic formula 1 by Cs is equal to 1 by C1 plus 1 by C2 plus etc. Capacitors connected in parallel is effective capacitance Cp is equal to C1 plus C2 plus C3 etc. Suppose three capacitors are given 1 microfarad, 2 microfarad, and 3 microfarad. Here it will be 1 by 1 plus 1 by 2 plus 1 by 3. When you calculate the resultant, 1 by Cs is equal to 1 by 1 plus 1 by 2 plus 1 by 3. 6 is the LCM. 6 plus 3 plus 2. 11 by 6. So Cs is equal to 6 by 11 microfarad. The resultant here is lesser than the least value in the problem. Least value in the problem is 1 microfarad. So the resultant in series connection is 6 by 11, which is lesser than 1. So like that you can remember. When you calculate the resultant will be lesser than the least value in the case of series connection. Parallel connection, 1 plus 2 plus 3, 6 microfarad. Greater than the greatest. Greatest in the problem is 3 microfarad. Your answer is 6 microfarad. So greater than the greatest. Okay. So keep these two in mind. We'll go to the problems. First problem. Two capacitors have a capacitance of 5 microfarad when connected in parallel and 1.2 microfarad when connected in series. Calculate their capacitances. In parallel, given as 5 microfarad, in series 1.2 microfarad. Calculate the capacitances. C1 and C2 you have to calculate. Parallel connection basic formula C1 plus C2 is equal to 5. 1 by Cs is equal to 1 by C1 plus 1 by C2. 1 by Cs is equal to C1 plus C2 by C1 C2. Cs will be C1 C2 by C1 plus C2. That is given as 1.2 microfarad. 1.2 microfarad. So cross multiply C1 C2 is equal to C1 plus C2 into 1.2. C1 plus C2 is 5. 5 into 1.2. 6 microfarad. So product of two number is 6. Sum of two number is 5. Therefore, the numbers are 2 and 3. 2 microfarad into 3 is 6. 6 microfarad. Here also microfarad. So it will become microfarad square. 2 microfarad plus 3 microfarad is 5. Okay. Simple problem. Second one. Two capacitors of equal capacitance when connected in series have net capacitance C1 and when connected in parallel net capacitance is C2. What is the value of C1 by C2? two capacitors of equal capacitance. 1 by Cs is equal to 1 by C plus 1 by C, that is 2 by C. So Cs is equal to C by 2. What is this value given? C1. Okay. In parallel, Cp is equal to C plus C 2C. That is given as C2. Question is calculate C1 by C2. Therefore, C1 by C2 is equal to C by 2 by 2C. C get cancelled. So answer is 1:4. Ratio of capacitance in series by capacitance in parallel. That is 1/4 or 1:4. This is second problem. Third, the capacities of three capacitors are in the ratio 1:2:3. Their equivalent capacity in parallel is greater than the equivalent capacity in series by 60 by 11 microfarad. Calculate the individual capacitors. Third, given 1:2:3 capacitance ratio 1:2:3. That means what is the value? C 2C 3C. Correct? In parallel, what is the formula? Cp is equal to C1 plus C2 plus C3, C plus 2C plus 3C, 6C. In series, 1 by C plus 1 by 2C plus 1 by 3C. Take 6C as LCM, 6 plus 3 plus 2, 11 by 6C. Cs is equal to 6C by 11. Greater minus smaller capacitor in parallel with series difference. Cp minus Cs given as 60 by 11. What is Cp? 11 6C minus Cs is 6C by 11 is equal to 60 by 11 microfarad. Cross multiply 66C minus 6C by 11 is equal to 60 by 11. 11 get cancelled. 60C is equal to 60 is equal to 1 microfarad. So C1 will be so when you calculate this one, it is 66C minus 6C by 11 is equal to 60 by 11. Simplify 60C 11 get cancelled. 60C is equal to 60. C is equal to 1 microfarad. Therefore, C1 is 1, C2 is twice 2, C3 is thrice 3. 1 microfarad, 2 microfarad, and 3 microfarad. This is the resultant. Fourth problem. The equivalent capacitance of the combination between A and B is 4 microfarad. Calculate the capacitance of the capacitor. First one. Second one, calculate charge on each capacitor if a 12-volt battery is connected across A and B. Third, what will be the potential drop across each capacitor? Question, you have one capacitor, another capacitor connected between A and C. This is 20 microfarad. This is C given. You have to calculate calculate the capacitance C. These two are connected in series. Therefore, 1 by Cs is equal to 1 by 20 plus 1 by C. When you calculate C plus 20 by 20C, what is the value given? The resultant is 4 microfarad. 4 microfarad. No. Cs is equal to 20C by C plus 20. That is 4 microfarad. So 20C is equal to 4C plus 80. 16C is equal to 80. C is equal to 80 by 16. That is 5 microfarad. So in series, you have to connect 5 microfarad here. Then only we'll get the resultant as 4. So this is the first step. You have calculated the value of C to be connected. Second, calculate the charge on each capacitor if a 12 volt battery is connected across A and B. This is A and B. 12 volt battery is connected across A and B. You have to calculate the charge. You know very well, in series, charge is same. In parallel connection, potential difference is equal. In series connection, charge is equal. So this is the basic concept. When you connect the capacitors in series with a potential, this potential V divided by V1, V2, V3 here. Whereas the charge across these three capacitors are same. Whereas in parallel connection, when you connect with a battery, starting point, ending point is same. So potential difference across all the three capacitors are equal. But charge across this will be different. Same case, we're going to talk in terms of resistors in the next topic. So you have to calculate the charge on each capacitor. What is the value? Q is equal to C into V. What is C value? My resultant value? 4 microfarad. So 4 into 12. 48 microcoulomb. Total charge is 48 microcoulomb. Correct? Next, third one. Potential difference across 20 microfarad. Take it as V1. V is equal to Q by C. V1 is equal to Q by C in our case. This is not C, 20 microfarad, so C dash. What is Q here? 48. 48 into 10 power minus 6 by C dash. 20 into 10 power minus 6. 48 by 20. 12 by 5. 2.4 volt. Similarly, potential difference across C we have to calculate. V2 is equal to Q by C. 48 into 10 power minus 6 by C are calculated as 5. 5 into 10 power minus 6. That is 9.6 volt. Sir, total, you can cross check the answer. Total is 12 volts. V is equal to V1 plus V2 here. So, you have calculated 2.4 now. Without doing this, you can calculate V2. 12 minus V is equal to V1 plus V2. Total is 12. You have calculated as 2.4. 12 minus 2.4 will give you V2. You can otherwise cross check the answer. Add these two. So 2.4 plus 9.6, 12 volts. You can cross check your answer. So potential will be added up here to get the total. Correct? So this is the fourth problem. Fifth one. How would you connect 8 microfarad, 12 microfarad and 24 microfarad capacitors to obtain minimum capacitance and maximum capacitance? If a potential difference of 100 volt is applied across the system, what would be the charges on the capacitors in each case? Sir, first you have to calculate minimum capacitance. Second, you have to calculate maximum capacitance. For minimum capacitance, capacitors should be connected in series. Then only you get the lowest value. Highest maximum value means you have to connect in parallel. In series means minimum value. So what are the data given? 8 microfarad, 12 microfarad, 24 microfarad. 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. 1 by 8 plus 1 by 12 plus 1 by 24. LCM 24, 3 plus 2 plus 1, 6 by 24. 1 by Cs is equal to 6 by 24. Cs is 24 by 6, that is 4 microfarad. Minimum value. Already we have learned the principle. The value what we are getting is lesser than the least. Least is 8. We are getting only 4. Maximum capacitance. For maximum capacitance, Cp is equal to C1 plus C2 plus C3. That is 8 plus 12 plus 24. 44 microfarad. Third, you have to calculate the total charge across the system. Potential is 100 volt. In series, charge is same, you know. In series, Q is equal to Cs into V. All the three capacitors, same charge. What is Cs value? 4. 4 into 10 power minus 6, 100 volt, 0.04 microcoulomb. In parallel, Q1 is equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. In parallel, potential only constant. Charge is different. That is Q1 is equal to C1, 8 microfarad, 12 microfarad, 24 microfarad. Everything multiplied by 100 volts. 0.08 microcoulomb, 0.12 microcoulomb, 0.24 microcoulomb. 8 into 10 power minus 6. So 800 microcoulomb. This is 1200 microcoulomb. This is 2400 microcoulomb. Correct? Simple. So you calculate the charge in series connection as well as in parallel connection. Sixth problem. Calculate the capacitance of capacitor as shown. If the equivalent capacitance of the combination between A and C is 15 microfarad. Sixth one. 2 in parallel connected in series with another capacitor. Across A and C, resultant capacitance you have to calculate. What are the two capacitors? 10 microfarad, 10 microfarad. You know very well these two connected in parallel. So I can write 10 plus 10, 20 microfarad. This 20 microfarad and one more C is connected. You can take it as B because capacitor C means confusion will come. So 20 microfarad, this is C. So between A and B only article. These two are in series. So 1 by Cs is equal to 1 by 20 plus 1 by C. 1 by Cs is equal to C plus 20 by 20C. Cs is equal to 20C by C plus 20. The resultant capacitance given as 15 microfarad. 15. So 20C is equal to 15C plus 300. 5C is equal to 300. C is equal to 300 by 5. 60 microfarad. So the capacitor to be connected here to get the resultant 15 microfarad is 60. Basic concept if you understand, then step by step every problem you can do. Basic. Next, seventh problem. 4 capacitors given as shown. Calculate the combination of the capacitors between P and Q. Find the value of each capacitor. Between P and Q, the 4 capacitors are connected. You have to calculate the value of each capacitor. Diagram. between P and Q. The resultant capacitance given as 1 microfarad. From the diagram, it is very clear. See, starting here, then it is continuous. That means all are connected in series. All are connected in series. So I can write 1 by Cs is equal to 1 by C plus 1 by C plus 1 by C plus 1 by C. 4 identical capacitors only question. So that is 4 by C. Cs is equal to C by 4. That is 1 microfarad. So C is equal to 4 micro. So C1, C2, C3, C4, all 4 are identical. 4, 4, 4, 4 microfarad connected in series. Straight. Next. Calculate the equivalent capacitance between the points A and B as shown. Eighth problem. Between A and B, 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad. 5 capacitors are given. First two connected in parallel, last two connected in parallel. With these two, 1 microfarad is connected in series. Simple problem. Basic formula, these two connected in parallel. So Cp is equal to C1 plus C2, 1 plus 1, 2 microfarad. So when you calculate, this is also 2 microfarad. So the new diagram will be 2 microfarad, 1 microfarad, 2 microfarad. These three connected in series. So the resultant value will be 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. 1 by 2 plus 1 by 1 plus 1 by 2. 1 by 2 plus 1 by 2, 1. This is 1. So 2. 1 by Cs is equal to 2 microfarad. Cs is equal to 1 by 2 microfarad. That is 0.5 microfarad. Simple. Otherwise, you can take the LCM as 2, 1 plus 2 plus 1, 4 by 2. 4 by 2 is nothing but 2. Anyway, you can write. Ninth problem. Four capacitors of equal capacitances are connected in series with a battery of 10 volts as shown. The middle point B is connected to Earth. What will be the potentials of the points A and C? Ten volts. This is 10 volt. Here two capacitors, here two capacitors. Point A, point B, point C. B is grounded. This is the question. B is grounded. When B is grounded, its potential is 0. So the potential difference between these 2 points and these 2 points should be same. Potential difference. not potential, potential difference. Because this is grounded, this potential difference and this potential difference are equal. Implies VB minus VA is equal to VC minus VB. 2VB is VA plus VC. That is 0. Implies VA is equal to minus VC. Total is 10 volt. Total potential is 10 volt. So this potential difference and this potential difference is sum only 10 volts. Implies VA is equal to 5 volt. VC is equal to minus 5. These two 0 at the point B. Correct? Straight problem. 10th problem. A variable capacitor has n plates and the distance between successive plate is D. Determine its capacitance. Parallel plate capacitor. Question. Parallel plate capacitor. C. It depends upon the area and distance between the two plates. So two plates means the formula says C is equal to epsilon naught A by D. For n plates, this is for two plates. C dash is equal to n minus 1 epsilon naught A by D. Simple. How many plates you have? Minus 1. 2 plates means 1 epsilon naught A by D. 5 plates means 4 epsilon naught A by D. N plate means n minus 1 epsilon naught A by D. Basic formula. 11th one. A network of 4 capacitors, each of 12 microfarad capacitors, is connected to a 500 volt supply as shown. Determine equivalent capacitance of the network, charge on each capacitor. Four capacitors, each of 12 microfarad is connected to 500 volts. This is 500 volt given C1, C2, C3. When you draw capacitors, two plates should be of same size. One is bigger, one is smaller, means it is not a capacitor, it is a potential. Plus minus. So meaning will change. Accordingly, you write. From the diagram, it is very clear that C1, C2, C3 are in series. Series. So 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. What is the value given? All are 12 microfarad. So 1 by 12 plus 1 by 12 plus 1 by 12. 1 by Cs is equal to 3 by 12. That is 1 by 4. Cs is equal to 4 microfarad. This 4 microfarad is in parallel with the C4. So, another diagram. This is 500 volt. CS is 4 microfarad. C4 is 12 microfarad. Therefore, Cp is equal to C1 plus C2, that is 16 micro. Correct? What you have to calculate here after calculating resultant capacitance, you have to calculate the charge. In series, charge is same. That is Q1, Q2, Q3. All the three capacitors will have same charge. Cs into V. What is Cs calculation? 4 microfarad. What is V value given? 500 volts. (2000 microcoulomb). 2 into 10 power minus 3 coulomb. There also for capacitor C4, what is the charge you have to calculate? Q4 is equal to C4 into V. What is C4? 12 microfarad. What is V potential? 500. 60. 6000. 6 into 10 power minus 3. This is 2 into 10 power minus 3. This is 6 into 10 power minus 3. Correct? Next. 12th problem. A parallel plate capacitor filled with mica having epsilon R is equal to 5 is connected to 10 volt battery. Area of parallel plate is 6 meters square. Separation distance is 6 millimeter. Find the capacitance, stored charge and stored energy. Capacitance you have to calculate, charge you have to calculate, stored energy you have to calculate. Three things is asked. Parallel plate capacitor C is equal to epsilon naught A by D. Basic formula. But in the question they have given dielectric constant. Dielectric constant, another is relative permeability. Permittivity. Relative permittivity. Mu or only relative permeability. This is relative permittivity. Epsilon naught A by D is C value. Epsilon naught 8.854 10 power minus 12. Epsilon R is 5. Area 6 meters square. Distance is 6 millimeter. 6 meters square. 6 millimeter. 6 cancelled. C is equal to 8.854 into 5. 10 power minus 12 plus 3. Simplify. You will get the answer 44.25 nano coulomb. 10 power minus 9. So nano. Capacitance. So nanofarad. (44.25). Next, charge you have to calculate. Charge and energy you have to calculate. Charge Q is equal to C into V. C value 44.25 into 10 power minus 9. What is the potential given, ma? 10-volt battery connected to 10-volt battery. So I can write 44.25 into 10 power minus 8 or 442.5 nanocoulomb. Second. Third, what is the energy stored? What is the energy stored formula? Energy U is equal to half CV square. Basic formula half CV square. So U is equal to half C. What is C value? 44.25 into 10 power minus 9 into V potential 10 volts. So it will become 100. 100 will go as 10 power minus 2. So minus 9 minus 2 is minus 11. 44.25 by 2. 22.17 joules. 22.17 nearly joules. 10 power minus 7. Minus 9 plus 2. Minus 7. That is 221.7 microjoules. Correct, Amma? Next problem. For the resultant, for the capacitance given, calculate the resultant capacitors. C1, C2, C3, C4. This is given as 9 volt. C1 value 8, 6, 2, 8. 8, 6, 2, 8. Calculate the resultant capacitance. You can calculate the charge, you can calculate the potential difference. Same concept. Any concept, first you calculate the resultant capacitance. Afterwards, in series means charge is same. In parallel means potential is same. You can calculate accordingly. So here resultant is these two are in parallel. So C1 CT is equal to 6 plus 2, 8 microfarad. So new diagram C1 CP C4. What is C1? 8 microfarad. CP, these two together, 8 microfarad. C4, that is also 8 microfarad. All the three in series. So 1 by CS is equal to 1 by 8 plus 1 by 8 plus 1 by 3 by 8. CS is equal to 8 by 3. Straight problem. In series, resultant will be 8, 8, 8. 1 by 8 plus 1 by 8 plus 1 by 8, 3 by 8. CS only we need. So reciprocal. Charge on the capacitor mean these two charge is different. Total 9 volt. 9 volt is divided across all the three. Here 8, here 8, here 8. We want to calculate the potential. V1, V2, V3 is equal to 9. All C is same. So 3 volts, 3 volts, 3 volts. So 3 volts here, 3 volts here, 3 volts. The potential you know, Capacitance, calculate the charge. Q is equal to CV. You can very well calculate the charge and very well calculate the total potential. Correct, Amma? Thank you. We'll continue.